Can you guys write the name? Really? That's a useful name. Okay, so first of all, do you guys have any questions that you need to ask about the exam? Like which part is that's the question, you know?
Thank you.
Like, if not, I can provide you some of the questions that are like pretty sure it will be on the exam.
Yeah.
Yeah, that would be great. Okay, so one of the questions that I do know will be on the exam will be drawing the polar equation. So what he will give you, I'm trying to find an example for this one. So he'll give you a graph like this one. Can you say? Can you guys see it?
Do I need to?
Sure. Off the line here. I mean, it will completely turn everything off.
This one.
Like this one.
Is it cool?
Yeah. Okay, so what it's going to give you is a graph like this with this is a polar. This is a polar graph, if you guys know that. And he will give you a graph like this. This will range from 0, pi over 2. This is, I think, pi, and 3 pi over 4. And he will give you an equation, like, and he will give you like a very small graph with r here and theta here with very specific value. Like, it will be like the equation that range from like this one, and he will ask you to transform this this graph into this one, and this will be like a 10-point questions, and will be the very last one from the last exam, as I remember. And so, you guys know how to do it?
Kind of.
Okay, so I'll give you an example. What are you going to try to do is you will try to come up with a table with a value, like I think 3 or 4 points will go to the point where you can graph. Okay, I have one example right here, which is you have to come up with a table with the value of r and the value of theta, like this one. I don't exactly like remember the graph, but it will have you can transform it to a table with the value of r and theta, and like with a specific value of theta, you have a specific value of r. So like for this example, like if you have the value of theta is 0, r will be -1.
What's the equation for
It will be r equal to 1 minus 2 cosine of theta. Okay, so when theta is equal to 0, theta equal to 0, r will be -1. When theta equal to pi over 6, you can always deduct this one from the graph. He will provide you 0.7 and pi over 4. It will be -0.4.
Will we usually have to use a calculator to get these numbers?
Are you guys allowed calculator in the exam? No, right? But he will provide you a graph from that graph. Like he will provide you the graph of r and theta, and from that graph you can have like very specific value. The value don't need to be very specific like this one. Maybe you just need like from 0 to pi over 4 and something. This one is just like a demonstration of how you're gonna do it. And and so on, right? Pi over 2, it will go to 1, and 2 pi over 3 will be equal to 2. So what you're gonna do is like you're gonna have to draw this table inside this graph. So the first range you're gonna see is from 0 to pi over 6, right? So starting from here and to pi over 6 is here, right? So the first one, for the first range of 0 to pi over 6, I will range from -1 to -0.7. So each of this circle is 1 unit of radius. So this one will be equal to r equal to 1. This one is r equal to 2, and this one is r equal to 3, and so on. So from theta range from 0 to pi over 6, but r is now like, but r is negative, so you have to draw it on the range that is symmetric to this part, to this region. It will have to go from here. So r will go from this one. R will go from 1. When it is at 0, it will go from 1, and then when it reach pi over 6, it will be -0.7. In this case, it will be 0.7, so it will go here, right? And for the second range, pi over 6 to pi over 4. Okay, I guess pi over 4 is this one. And it's still because the r is negative, so you have to draw it on the region that is symmetric to this one. And it will go from 0.7 to 0.4, so we'll go back here, like a little bit like this. The next regions will be pi over 4 to pi over 3. And it would be like this. And because it started from negative and it goes to 0, so we know that it will come back, like r will come back here, right? So it will have to go from here back to the origin. So you have this one is the curve now, And you're gonna keep doing that until you finish the whole region. Yeah. So do you guys have any question? So this is a 10-point questions, and this will be the last question. Normally the second exam will be the hardest one. So. The second question that I know we will ask will be on differential equations. So the second question will be on differential equations. So the first type of differential equations will be have an equation and you have to transform it from like how you're gonna solve this one, solve this equation, this kind of equation. So all you have to do is change the sign of these two and make all the y in one side and all the x in one side, and you will look like this one. And then what you're trying to do is try to integrating y dy and integrating x dx. And when you completely solve it, just try to make an equation where y equal to fx. So that's one type of differential equation. The second type of differential equation is the linear equation. For linear equations, you have an equation that looks like this. Yes. That's y equal to q of x. So make sure that on this side, if we for dy over dx, it only contains a dy over dx, nothing else. If you have some constant or variable before that, you have to divide the whole equation with that constant. So I'll try to give you guys an example after that. And what you're gonna do for this one is you're gonna multiply both sides with a constant I, so not constant, which is equal to e to the integrations of dx dx, and u times I into both sides of the equations, and then you try to solve the problem from there. And that's the differential equations. And one question will be on the Euler's method. Not really remember about the Euler's method.
Can you do an example of each type of those differential equations?
Oh, sure. Okay. I think I will put out one of your homework assignment. I think I can do this one from the book. So for the linear equation, so this one is square times y prime plus xy equal to 1. So as I said before, there can be no like x squared here. This variable can only contain y prime. So what are you going to do is like you're going to have to divide both sides by x squared. So it will be equal to y prime plus y over x equal 1 over x squared. And then you will try to find I, which is equal to e to the integrations of px, right? So so you know that px here is 1 over x, correct? So it will be e to the integration of 1 over x dx. In here, you ignore the constant that goes behind it. So it will be e to the natural log of s. Right? Yeah. And so it also equal to x. Like luckily, you're equal to x. And now you're gonna plug x, like this value here, back into the equations, and it will give you x y prime plus y equal to 1 over x. Right? And then you're gonna have to try to solve this one. So the purpose of trying to find I is that because when you have is that you try to like substitute like try to make this one into a addition of integrations. Like you have like uv prime equal to u v primes plus u prime v, right? So the purpose of finding an I is to like trying to combine these two, become these like these two factors, and then try to combine them into one single derivative. And so I think for this one we will have x y prime x y up. So x sorry, it's been like very long. But yeah, it's gonna be like this one because okay, yeah. It's gonna be like this one, like x, y derivative, and this one is 1 over x. And it is because when you have like x times y prime, plus y plus y, like in this case, x will be u and y will be v, right? So it will go down to this one. And from now, you just integrating both sides. This one luckily will equal to xy because this side and this side eliminate each other. Right? So xy will equal to -1 over square. And y will equal to -1 over x.
Isn't it natural log of x? You integrate 1 over x.
Oh, good. Sorry, it's been very like very here now. Okay, sure. Like these two are like very good feeling for the derivative and for the integration. And so we have y equal to natural log of x over x plus c over x. So how are you going to do the that's how you're going to do the line equations.
What was the original equation?
The original equations is x squared plus y prime plus y over x equal to 1. Is it? xy equal to 1. So that's how you're going to solve the linear equation. Do you guys have any more questions? So I know that one question will be also on the Euler's method, which is the step that you guys take, like which is the calculation with the steps, like with step h equal to 0.1. Do you guys need an example on that?
Sure.
No worries. One question will absolutely on the improper integral on second point A. Ask you for the type of it.
The type.
Like, sorry, solving the improper integral. And how you're going to solve it. One question will be on the Euler's method. One question will be on separable equations. One question will ask you to actually draw the curves by the parametric equations. Like it gives you the value of x and the value of y according to t. Then you guys have to draw it on the graph, right? And show which is the initial point and which is the terminal point for the equations. Like pretty much this exam is like pretty much about drawing and like working with the graph. One question will ask you about the area in the polar coordinate. Make sure to know how to calculate the area with the flower graph.
What is that equation?
Like if you have the graph like this one, usually is trigonometric functions, and he will ask you to find the area like of one of the leaves of the flower. So what I'm trying to do is like just finding the range of it, and it will be equal to, like for this one, it will be ranging from 0 to pi over 4, right? So the equation will be pi over 4 and 1 over 2, sorry, it will be like 0 to pi over 4 of 1 over 2 times r squared d theta. And you plug in the equations for r here, and then times 2. Because 0 to pi over 4 is just like half of the ellipse, and you have to find the area of the other one. There's no point like trying to find the whole thing or something, because you can break that into 2 halves. Like last semester, we asked about the one with like, I remember 6 leaves or something. But it's pretty much the same. And
Will we be given R, or will we have to find it as well?
we will be given R, and he will ask you to find the area of it, like the area of one of these.
That's just the equations.
So you have the equations for area is A equal to the range meter of 1 over 2 times r squared d theta. I think this is the general equations, general formula for this one. And you just need to plug it in. But what you're gonna really have to do is trying to solve the integrations. And first you have to find the range of it. So if it is a flowers, if it is a leaves, just trying to like finding half of the area and times 2 to make the whole area. Because like this area and this area are like basically the same. That will be one question on the exam. And this one is like, this exam is like the hardest one for me. So yeah, there will be one of the separable equations.
On the what?
On the separable equations, which is like dy over dx. And equal to fx times gy. Like this is an equations according to x, to y, and this is equation according to x. And you try to group all the y and dy together, and grouping all the x and dx together, and like you have both sides like this one, and you will try to integrate it. And after you integrate it, don't forget the constant. Don't forget to plus c on both sides. And like, let me show you guys an example. So one example will be like this. So you will try to group all the y and all the x together. So you just multiply this one by y squared and a squared dx, right? And then you integrate both sides which leads you to y squared with 3 plus c1, and this one is x cubed over 3 plus c2. Like the constant is really important. If you guys forget it, I think it will cost you half of the points for that one. So it will be y cubed over 3 equal to x cubed over 3 plus c2 minus c1. You can group this one and change it to k. Like now the constants, doesn't matter. And y cubed will be equal to, actually let's not group it as k right now. And it will be to x cubed plus 3 c2 minus c1. And now this one will be k. And you have y equal to this. Now, if you forget the constant, it will be like completely different. So, like completely different answer. So, try to really trying to remember the constant. All right. Do you guys have any more questions? And one question is we're trying to ask you solve the derivative of a parametric equation, like second derivative. So try to remember that. Try to remember the formula for the second derivative. This is very different. Right.
Do you have any example of that?
Of second derivative?
Oh, parametric equations. Yep.
Okay, so the formula, like, it'll be on 10.2. The formula for the first derivative will be dy over dx will be equal to dy over dt or dx over dt. And then the second derivative of these equations will be d over dx of dy over dx. And you know that dy over dx is this one, so it will equal to d over dt of dy over dx over dx over dt. So this is the equations for the second derivative. So if you want to try to solve the second derivative, you must solve the first derivative first, and then plug it in here to find the second derivative. This is very different from the regular derivation. I think it will be one example in the textbook. But this assignment is like really long, so try to do that whenever you have time. Or try to find the first derivative, and that will be fine. I think one of your assignments is one. Okay. That's going to be very, very long. So it's just like the first assignment already. So for the first problem in your homework solution, it's equal to E over T and Y over T e to minus T. Finding, first you have to find dy over dx. So it will be dy over dt and dx over dt, which leads to dy over dt will be minus 1.
E to the minus t.
Sorry?
So it should be e to the minus t.
I think it should be. Oh. This one is still e to the t. And what do you say about the first one?
The e to the minus t. Because it's multiplied by minus 1 there, right? Y equals minus 1 times e to the minus t, right?
Yeah.
That's like, so the derivative of that would just be e to the minus t.
So
Yeah.
I think this one stay the same. Oh,
The point
this
is
one
it's-
will e to the minus t, right?
Yes.
And then because it's multiplication,
Right.
so minus t, right?
Wait, is that t times e to the minus t, or is that minus 1 times e to the minus t? What does y equal?
Okay, it's y. Oh, sorry, this one is t.
Okay.
Sorry. And minus t. Sorry, the bar is like really hard to use. It's just like, and it will be 1 minus t to e to minus t. And what down there is e to t. And yeah, so that is dy over dx. And now you have to find the second derivative of it, which is
Divided by e to the power of t again.
you have to first derivative this one,
Again?
Yeah.
the whole part, yeah.
And then you put it over e to the t.
And you have to put it over e to the t.
Okay.
I don't think you ask you to do that long. I remember that there's some kind of simplifications in the exam, but that's the whole idea of it. Like you have to derivative this one and then over dx over dt. So anyway, it's going to be a very long assignment if he did not provide you like any way to simplify it. So yeah. Okay, I think that's pretty much everything I remember about the exam that I can provide you guys. Do you guys have any questions? Like any specific part that you guys are working on?
You know how many questions will they come?
For the what?
Because exam 1 has 12 questions. Will this have 12 or?
Yeah. Yeah. And you guys have the draw graph, so yeah. So it's like it will be very likely that if you guys do really bad on the exam, it will like give you a retake like again. So
The retakes are way harder.
yeah, the retake is like way harder, and I got the score for the retake is like lower than for the real one. So he did not have me anyway. So try to do everything like good on this one. There will be like 12 questions. I'm trying to like remember what on there also. Oh yeah, so you have to remember also the circle. So x will be equal to r cosine of t, and y will be equal to r sine of t. I remember there's some questions that he asked you trying to find r, like trying to find r, or like he gave you x and y, and he will ask you like what is the radius of this one, how are you gonna solve that?
Can you give an example?
Okay, I'm
This
not
is the
really
one that you square them and then you add them up together and you end up like cosine squared plus sine squared is 1, so you end up like x squared plus y squared equals radius or something like that.
Yeah, but like I don't really I don't really remember the what kind of problem we can do. I'm trying to find it. Oh, yeah, okay. So it's the example 3 in 10.1. So he'll ask you a question like that. So like really try to look at the example in the book because he cannot ask like beyond that. And also the homework. So like x will be the sine of 2t and y equals to cosine of, is it? That was weird. And like this. And try not to confuse between the two over here and the two might happen over here. Like the two might happen in here would be r, would be the radius. But this one in here is just like this two in here is just like indicating the speed of the circle. So which means the radius of this circle will still be 1 because sine square of 2t plus cosine square of 2t will also be equal 1. So it will the radius will be 1. But by the time that you actually reach 1, like by the time it goes from 0 to 2 pi, it actually like goes twice. This part is like by the time you reach 2 pi, it actually like going to circle already. He will ask you that, like he'll actually like giving these equations, how you're gonna do it, or like how you're gonna draw it, how you're gonna draw the graph. And you just say that it will also be a circle with radius equal to 1, but because it ranges from 0 to 2 pi, it actually goes twice the circle. So he will ask you one question just like that. And yeah, I remember there's a lot of drawing in the exam. So everyone did pretty bad. Last year average was like 40%. So everybody qualified.
Did he curve it?
No, it didn't actually give us the retake. And I think somehow magically in the end of the semester it just raised everything up. Like it depends. It depends on the class. I'm not really sure. Yeah, that's pretty much it. It's the hardest one because the final exam will also contain the final exam because it will also contain the graph with all the circles, and everybody got trouble with drawing the circle, like drawing the polar equations, and that one is actually very easy if you guys actually learn. But because he only talked about it in class, and I never did some class before, so I skipped that part for the first exam, and there's like 10 points on that. That costs 10 points, and you have like 12 assignments, 12 problems. So it's very important. Oh yeah, so try to remember this. This also, if x equal to h plus r sine t and y equal to k plus r cosine t, h and k will be the origin, where the center is. Sorry. So h, k will be the center of the circle. That's it. Like if he asks you to describe it, try to come up with the center, the radius, and how it goes. Like twice or one time or something. And that's pretty much it. Okay. You guys have any more questions? Okay, so if you know, like, or we can go now. You can still like email me with your questions if you guys have anything. You still have like 8 hours, 12 hours to study. Yeah. It's fine. Study is one of the hardest less two classes. Good luck, guys. You good? Pretty much it.